Exoplanets are the planets that orbit stars outside of our solar system. They are often referred to as extrasolar planets. The existence of exoplanets was first suggested in the early 20th century, but it wasn't until the 1990s that the first exoplanet was discovered. Since then, thousands of exoplanets have been identified, and the study of exoplanets has become a rapidly growing field of research in astrophysics. Most of the planets that exist beyond our solar system orbit stars. The stars can be of various types. You want to know more about them? Make sure you subscribe and turn the notification on, so that you don't miss out when it comes out. By the way, free-floating exoplanets, called rogue planets, orbit the galactic center and are untethered to any star. Although exoplanets are far, even the closest known exoplanet to Earth, Proxima Centauri b, is still about 4 light-years away. Scientists have discovered creative ways to spot these seemingly tiny objects. There are 5 methods scientists commonly use to discover exoplanets. The 2 main techniques are the transit and radial velocity methods. One of the most common methods of finding exoplanets is through the transit method. When a planet passes directly between an observer and the star it orbits, it blocks some of that starlight. For a brief period of time, that star's light actually gets dimmer. It's a tiny change, but it's enough to clue astronomers into the presence of an exoplanet around a distant star. Stars are affected by the gravitational pull of their orbiting planets, and when observed through a telescope, this affects the star's light spectrum. If the star moves in the direction of the observer, it will appear to be shifted toward blue. If it is moving away from the observer, it will shift toward the red. Observing this is known as the radial velocity method. Gravitational microlensing is a phenomenon that occurs when a celestial object, such as a star, passes in front of another star. As the foreground star passes between the observer and the background star, its gravitational field bends and focuses the light from the background star, causing it to appear brighter to the observer. This increase in brightness is temporary and can last for a few days to a few weeks, depending on the alignment of the stars and the distance between them. The first exoplanets were discovered in the 1990s, and since then thousands have been identified, using a variety of detection methods. It's pretty rare for astronomers to see an exoplanet through their telescopes, the way you might see Saturn through a telescope from Earth. That's called direct imaging, and only a handful of exoplanets have been found through this method. In astronomy, direct imaging is a technique used to observe and photograph planets and other celestial objects directly, rather than inferring their presence through indirect methods such as spectroscopy or photometry. This is achieved by using telescopes with specialized instruments, such as coronagraphs or starshades, that are designed to block out the light from the star and allow the light from the planet to be detected. There are several advantages to using direct imaging to study planets. One advantage is that it allows scientists to directly observe the planets and their atmospheres, rather than relying on indirect methods that may not provide as much information. Additionally, direct imaging allows for the possibility of detecting planets that are too far from their star to be detected through other methods, such as radial velocity or transit photometry. However, direct imaging also has some limitations. One limitation is that it is difficult to detect planets that are very close to their star, as the glare from the star can obscure the light from the planet. Additionally, direct imaging is typically only able to detect planets that are relatively large and that are far from their star, as smaller planets and those that are closer to their star may not be bright enough to be detected. Overall, direct imaging is an important technique in the field of exoplanet research, as it allows scientists to directly observe and study planets that are beyond our own solar system. Astrometry is the branch of astronomy that deals with the precise measurement of the positions and movements of celestial objects. This includes the measurement of the positions of stars, galaxies, and other objects in the sky, as well as the study of the proper motions, parallaxes, and other physical properties of these objects. Astrometry is used to create precise maps of the sky, to determine the distance to celestial objects, to measure the expansion of the universe, and for many other purposes. Astrometry is a key aspect of many areas of modern astronomy, including the study of the formation and evolution of galaxies, the search for planets around other stars, and the study of the structure and dynamics of the Milky Way galaxy. It is also an important tool in the fields of celestial mechanics and astrogeology, which use the precise positions and movements of celestial objects to understand the evolution and structure of the solar system and other planetary systems. So far, scientists have discovered 3,941 planets using the transit method, 1022 using the radial velocity method, 148 using gravitational microlensing, 2 planets discovered with the astrometry method, and 62 planets by direct imaging. So far, scientists have categorized exoplanets into the following types: gas giant, Neptunian, super-Earth, and terrestrial. Gas giants are planets the size of Saturn or Jupiter. More variety is hidden within these broad categories. Hot Jupiters, for instance, were among the first planet types found. Gas giants orbit so close to their stars that their temperatures soar into the thousands of degrees. Neptunian planets are similar in size to Neptune or Uranus in our solar system. They likely have a mixture of interior compositions, but all will have hydrogen and helium-dominated outer atmospheres and rocky cores. We're also discovering mini-Neptunes, planets smaller than Neptune and bigger than Earth. Terrestrial planets are Earth-sized and smaller, composed of rock, silicate, water, or carbon. Further investigation will determine whether some of them possess atmospheres, oceans, or other signs of habitability. Super-Earths are typically terrestrial planets that may or may not have atmospheres. They are more massive than Earth but lighter than Neptune. Rogue planets. These are planets that do not orbit a star and instead drift through space. They may have formed in a similar way to regular planets but were later ejected from their solar system. Now you might be wondering how an exoplanet has actually been named. The naming of exoplanets is governed by the International Astronomical Union, the same organization that is responsible for naming celestial objects and features in our solar system. According to the International Astronomical Union, exoplanets should be named after their host star, followed by a lowercase letter in alphabetical order, starting with B, for the first exoplanet discovered around that star. For example, the first exoplanet discovered around the star TRAPPIST-1 would be named TRAPPIST-1b. If there are multiple exoplanets in a single system, the exoplanets are designated with consecutive lowercase letters in order of their discovery. For example, the second exoplanet discovered in the TRAPPIST-1 system would be named TRAPPIST-1c, the third one would be named TRAPPIST-1d, and so on. It's worth noting that exoplanets can also have more colloquial names that the IAU does not officially recognize. These names are often chosen by the scientists who discover the exoplanets, or by the media to make them more easily recognizable to the general public. For example, the exoplanet Kepler-186f is often referred to as Earth's cousin because it is located in the habitable zone of its star and is similar in size to Earth. Now we live in a universe of exoplanets. The count of confirmed planets is in the thousands and rising. That's from only a small sampling of the galaxy as a whole. The count could rise to the tens of thousands within a decade as we increase the number and observing power of robotic telescopes lofted into space. Before I let you go, I wanted to tell you guys that it's so difficult to include every single detail about such a vast topic as exoplanets in like a 10-minute video. I addressed as much as I could. Hope you enjoyed it. And if you did, don't forget to like the video. Subscribe and follow us on YouTube, Facebook and Twitter. Share with your friends. See you soon.